Hey, what's up guys, this is Ouss from the TechCave. In this video series, we're going to explore a new page in our cave. We're gonna talk about the design, user experience, etc. Roughly speaking, a human-computer interaction. So, this is the first video of this topic in which we'll see a historical overview of this science. Various HCI concepts are going to be treated in the next videos. I bet you didn't see the flaw in the picture. This is one of the basic HCI concepts that you should take it off when you are coding GUIs, designing a system, or whatever. We'll go over it in details in the next courses. MIT professor Vannevar Bush was one of the most influential scientists in the American history. He and his followers focused on ways to make close personal connections between man and machine. In 1945, he wrote an article named As We Might Think, in which he presents his idea about applying science to more lofty and human pursuits. And he proposed a system of knowledge navigation using a device he called mimics. One of the properties of this device is associative indexing, which is enabling the user to quickly index and retrieve documents and create associations among them. Maybe that looks familiar for you, doesn't it? Unless you still live in 40s. Yes, it is a description of hyperlinks and bookmarks. This vision of Bush inspired the community of computer scientists who made major contributions to HCI in the 60s and beyond. By the end of the 40s, the term computing started to get bigger and stronger due to the appearance of transistors and integrated chips. Carl Licklider, the Director of Information Processing Techniques Office of the US Department of Defense's Advanced Research Projects Agency, believed that this computing power can be better used. So he financed research across the United States in order to realize that. He had a futuristic vision. He envisioned a lot of things before they were invented, like graphical computing, digital libraries, e-commerce, online banking, etc. This is how the concept of time-sharing computing was born, which is the sharing of computing resources among many users at the same time by means of multi-programming and multitasking. The purpose of the first interactive time-sharing system was simply to augment programming capabilities of the user, or simply the programmers. A strong collaboration between humans and machines started to grow up. Indeed, with the advent of time-sharing system, real human-computer interaction was now possible. Licklider has formed a team of engineers and psychologists at the MIT Lincoln Laboratory to look at ways that humans could interact more intuitively with computers and information could be presented with friendlier interface. One of his missions in that lab was developing computers for an air defense system that would detect an enemy attack and react expeditiously. It was known as SAGE, S-A-G-E, for semi-automatic ground environment. Using long-distance phone lines, SAGE was able to connect 23 tracking centers across the United States, and it was able to disseminate information on up to 400 fast-moving planes at once. This system was too complex and needed to enable its users to have instant interactions with its computers. And by the way, SAGE, it's pronounced Sage in French, which means wise. Rest assured guys, by the end of this series, you will be able to speak French just like Joey Tribbiani from Friends did. By dint of Licklider's background in psychology, he was called upon to help design the human-machine interfaces, and he formulated a set of theories about ways that would allow humans and machines to work cooperatively to solve problems. After this project, Licklider began to talk about what he called a truly SAGE system that would network not only air defense centers but also thinking centers. In other words, the digital world we have today. In 1962, Ivan Sutherland, a student at the MIT, blew the mind of the computer scientist community with his Sketchpad program. It is a computer program that was the first to use a graphical user interface, one that displayed icons and graphics on the display screen the way today's computers do. The graphics, which could be created and manipulated with a light pen, provided a beautiful new way for humans and computers to interact and gave new vision to the computer. It is now more than just data processing. The computer started to speak more human language, instead of human being forced to speak more like a computer. Since the early 50s, Douglas Engelbart, an American engineer and inventor, had the ambition to make computer technology a means of complementing human problem-solving ability. So he and his team at the Augmentation Research Center developed many magical ideas such as word processing and the mouse. They concentrated on developing the set of programming tools they would require in order to build more complex interactive systems, so that they can continue to be composed with other tools and the process continues. That is called bootstrapping. Engelbart designed a full-fledged augmentation system he called Online System, or NLS, which included many advanced resources that led to the personal computer revolution. One of the first demonstrations that the powerful tools could be made accessible to the computer novice was a graphics programming language for children called Logo. Seymour Papert and his colleagues designed a computer-controlled mechanical turtle that dragged a pen along a surface to trace its path. By typing English phrases such as go forward, turn left, the child could teach the turtle to draw more and more complicated figures. Alan Kay was deeply influenced by the work of both Engelbart and Papert. He realized that the ideal is the power of systems such as NLS mixed by the usability of logo programming. Kay and the founding team of researchers at the Xerox PARC worked on incorporating a powerful and simple visually based programming environment called Smalltalk for the personal computing hardware that was just becoming feasible. In 1981, the WIMP technology emerged. WIMP for Windows Icon, Menus and Pointers. As an extension of this technology, the metaphor concept has given a rise. It is to bring real-life concept to the design in order to increase the initial familiarity of the user with computer applications. A simple example is the desktop to place your files and folders, a garbage bin to put things you're not going to use anymore. And by the way, Xerox Alto and Star were the first workstations based on the metaphor of the Office desktop. After that, Windows and Apple got into the game. Between 86 and 89, a rise of intellectual participation took place. 7 books were published and were popular among researchers and people interested in the field. User-centered system design, a new perspective on human-computer interaction, readings in human-computer interaction, a multidisciplinary approach, handbook of human-computer interaction, psychology of everyday things, later reissued as design of everyday things, plans and situated action, computer-supported cooperative work, a book of readings, designing the user interface, strategies for effective human-computer interaction. In 1987, Apple published a book titled The Apple Human Interface Guidelines that encouraged different developers to adopt a common look and feel to their programs. Interface ideas and concept was previously freely borrowed. However, this notion of common look and feel of softwares resulted in multiple litigations and law cases taking place. Consequently, the solution of copyrighted software has been introduced, and this is something that strongly impacted the CHI community. Well guys, we're gonna stop here for this video. There are surely more leading figures and events related to the HCI's history that I couldn't mention, but I tried to talk about the ones I found most important. Hope you guys enjoyed the video. Don't forget to subscribe and wait for the next HCI courses. Tschüss!